Alright, welcome to the first video of Chapter 7. Okay, this will be your first chapter of the the third quarter. So, want to get off to a good start. Third quarter is always one that motivation kind of starts beginning to lack a little bit with students. So, please take everything I'm saying seriously because this is not a hard chapter, I don't think, but there's a lot to it. I mean, there's only 8 learning targets, but within each learning target is a lot of different things. So, this will be learning target number 1, so go ahead and flip to page 1. Okay, your learning target is I can write an algebraic expressions for numerical and real world situation. Okay, and we'll get into what that means down here a little bit. But you guys should know what an algebraic expression is. I mean, you know that an expression is operations and numbers. And when you throw the algebraic in front of it, then you know you're talking all of a sudden about variables. So now it's variables, numbers, and operations. Okay? That's what we want you to remember, okay? So for instance, something like x plus 9, that's an algebraic expression. Now, if you want to, we can look ahead to, like, I think it's chapter 8 or 9. If I had x plus 9 equals 12, that's not an algebraic expression anymore. That's an algebraic equation because it has an equal sign. Equation, equal sign. Okay, so that we'll get into that later, but I just wanted you to see it. An algebraic expression will never have an equal sign. Okay. First of all, here's some words. We made a little chart here for you. Basically, you should know most of these words, what they mean, what operations they mean. As I look here, first of all, let's look at like the word sum there. As you guys are aware, some of you struggle with these words. Okay. Hopefully we've hit them enough on review sheets to the point of you know them. Okay. But you got to know those 4. Those are definitely 4. Now the top row, kind of silly. I think you guys all know those. Don't necessarily like that one. Don't necessarily like that one, but you know that it could mean multiply. Others, divided equally, anytime you're cutting them into pieces, that kind of things. We're talking about division, and you can read through the rest of these if you'd like, but pretty much this little chart will help you if you ever get stuck on what operation it is giving you. So, okay. Use variables to represent unknown numbers and write addition expressions. So, remember, a variable is just an unknown number. It's exactly what it is, okay? I mean, that's what, when we say the variable x, we mean some number. We don't know what x is, but that's the whole point of using a variable, because you can't just leave it blank. You put something in to know, okay, it does equal something. We just don't know what yet, okay? So as you can see here, this is giving you, and I want to show you this real quick actually, and I would like you to write this. I've showed you this a million times on review sheets. Whoops. You could write, I meant to write multiply. It means the same thing. Product, multiply, same thing. Multiply. Wow. Okay. So remember, when you're adding, you do the part, and then you're adding another part, and you're getting a whole. Okay. And this should look familiar to you as I've done it on review sheets probably 4 or 5 times now. Same with multiplication. When you do part times a part, you're always getting a whole. Okay? And this is a very, very perfect example of that, because as you can see, this long bar right here, that's a total length. That's what we don't know. A total would also mean a whole amount. How much does it totally equal? So we know one part of it, we know another part of it, so we do the part plus the part to get the whole. And anytime we add or multiply, we always know the 2 parts, and we're trying to find the whole. Same with multiplication. We say we know that we have a garden and there are 4 rows of corn, and there are 5 corn stalks in each row. Then we would do 4 times 5, and then we would figure out that would mean that there would be 20 whole corn stalks there. So that's kind of where it comes from. But just keep that in mind, and then we'll get to division and subtraction a little later. Okay? Now, a ribbon of unknown length is taped to a 9-inch ribbon. What is the total length? So here you go. It's already done for you here, but you can see how they did it with a model. You won't have to use a model. It's kind of unnecessary, but the key word here is a ribbon of unknown length. So right away, you should have been saying, okay, that's X or M or C or G or whatever. Okay, you can call it whatever you want. It does not matter. Generally, we go with X, or we'll go with just like like if we're talking about a ribbon, we'll use R. Okay, so we know that a ribbon that we don't know how long it is taped to a 9-inch ribbon. We want to know what the total length is, so then we have X and we know 9. We tape them together. Well, what do we have? We have X plus 9. Okay, X plus 9. That is the expression. Now, does that give you an answer? Do you learn how long this is? No, but what you could do is you could get a ruler out or a tape measure, and you could measure from here to here, and then once you figured out that, you could subtract 9 from that, okay, and then get this. Or if you're going to get out a tape measure, I guess you could just measure from here to here. But the whole point is to draw the algebraic expression, and this skill is so important when we get to our equation chapter, because equations are when it gets really important, okay? Because as we know the algebraic expression is just the x, which we don't know how long that piece is right there. That piece right there, we don't know how long it is. And we're adding 9 inches to it. And let's say I knew the whole length was 17 inches. Well, now you can solve this equation to figure out exactly what x is, which hopefully you all are saying it's 8, because 8 plus 9 is 17. Okay? So writing algebraic expressions may not look important right now to be able to figure that out, but it will be once we get to the equations. Let's go ahead and go to the next page. Okay, here we go. A straw of length 10 centimeters is cut from a straw of 24 centimeters. What is the length of the remaining straw? So, again, you can look at this and say, okay, well, we don't know how long the remaining straw is. So what it is you're actually doing 24 minus x. Okay, 24 minus 10. I apologize. Okay, to be able to figure that out. So this is just basic stuff right now. You probably all are like, wow, this is really, really easy. It gets more challenging, but that's what it is. Okay? Now, up here, this is where you've got to know how to write the algebraic expression, because now a straw of 6 centimeters is cut from a straw of length y centimeters. So it's cut from that. Notice the word from. Okay? So that means this is the whole amount. Now, while I have this moment, may as well go ahead and write this. Subtract and division. Okay? Whenever you're doing subtraction, you know the whole. You're going to subtract one of the parts you know to get another part. Same with division. Whole divided by part equals part. Now, this shouldn't look new to you or confusing or anything, because you should all be sitting there saying, well, yeah, we've seen this several times, and hopefully you understand it. Okay, remember, when we add or multiply, we know we're trying to determine a whole amount. What is the total length? How many total pieces of fruit do I have? Those we're trying to determine a whole. Okay, when we use subtraction or division, we know the whole distance, and we're trying to figure out a part of it, like up here. We're trying to figure out what this length is. We know the whole, we know one of the parts, so we can subtract whole minus part to get this part right here. Okay? Well, the same goes down here. You know that y is your whole amount, and then you're going to subtract this part right here out. So y minus 6 is your algebraic expression. Now keep in mind that you can't do anything with this. This doesn't solve anything. This is not about trying to find the exact answer. That's really irrelevant right now. Okay? I mean, eventually I'm going to give you y, and you're going to have to write an equation. But for now, it's all about just determining that this, whatever y is, I could figure out what this is. Okay? If y was 10, then this would be 4. 10 minus 6 is 4. Okay? If y was 20, then the question mark here would be 14. Okay? So it's all about just writing it. Now, I want you to take special note about this right here. This is y and 6 are the terms. Okay, we'll talk about terms a little later in this chapter. You could simply just say y minus 6, or you could say y take away 6, or even you could say 6 from y, okay, because you're taking it from the whole of y, okay. But the other one I really want you to pay mind to, and I'd like you to maybe kind of circle this or something so that you really know that this is what it is. You could also say it as 6 less than y, and that might seem kind of weird. Okay, now we're going to practice these here in a little bit, probably on this video or next, and when recognizing, because most people see 6 less than y and they think it's 6 minus y, but that's not correct, because it's saying 6 less than that y amount, which means y minus 6. Okay, go ahead and go to the next page. Okay, here's just some practice that we'll do together. Okay, basic little word problems that you have to then make into algebraic expressions. So first of all, here we know that sum, if you need to look back to page number 2, you can, but hopefully you know that that's the answer to an addition problem, and then you'd write x plus 10 or 10 plus x. Now I want to take special moment here just to go over this property right here, commutative property. Please write this. Okay, this is something that you should have already you learned it in elementary school, but maybe you've just forgotten. What the commutative property says, it says that with addition and multiplication, order doesn't matter. And I'll give you an example here in just a minute. The order does not matter when you're doing adding or multiplying. Okay, so that means that if you did 4 plus 5, that equals 9. Well, if you flip the order, isn't that also 9? Same goes for multiplication. 3 times 9, that's 27, right? But if you do 9 times 3, that's 27. Now, just so you guys know, I know you know this, but the commutative property does not work with division or subtraction. Okay? And guys, if you haven't figured this out by now, it's all because of this. If you know there's a part and there's a part, it doesn't matter which part comes first. They're both parts. Okay? Same here. If you know you're multiplying a part times a part, they're the same thing. So it doesn't matter, because your ultimate goal is just to find the whole. But when you're doing division and subtraction, you know the whole. You can't divide the whole from the part, or it has to go in the order that it is. You have to have the whole amount, and you have to dividing out one of the parts to get the other part. Same with subtraction. Okay? So for instance, if I know that 12 divided by 2 equals 6, we can't say 2 divided by 12 is 6 also. 2 divided by 12 is less than 1, right? It's 1/6 or whatever that is as a decimal. So the commutative property does not extend to division and subtraction. Okay? Here's this one that I wanted to warn you of. Okay? A lot of people make the mistake here. Now, first of all, you see the word difference. You should know that means subtraction. Now, I'll show you what the mistake is first. They see 7 less than y, and a lot of students just simply go, oh, that's 7 minus y. But that is not correct. Okay? It's 7 less than y, so that's going to be y minus 7. Now, a strategy that you can use here is sometimes I like to just create a number, and I say, okay, 7 less than, instead of saying y, say 7 less than 10. Okay? What is 7 less than 10? Hopefully you're saying 3. Well, the only way to get to 3 is to do 10 minus 7. So that's the only one. That one's a kind of tricky one. Okay? Whenever you see the difference of something less than something, the order is actually backwards, because it's this less than this, which means y minus 7, or in this case 10 minus 7. Okay? All right. Jim is now Z years old, so they're just giving you that it's Z. His brother is 4 years older than Jim. Find his brother's age in terms of Z. Okay, go ahead and pause and try this one on your own. Okay, so what you're going to do here is you know that Z is how old Jim is. Okay, that's what we know. And if his brother is 4 years, then it's just going to be plus 4. Doesn't it make sense that if Jim is 30 years old, that his brother is 34? Wouldn't 30 plus 4 be 34? Okay, whenever it says in terms of z, all that means is write the algebraic expression that would represent it. Okay? Now, Jim's sister is 3 years younger than him. So now it's going to be Jim's age minus 3, right? Because we're taking Jim's age. Again, if he's 30, if his sister's 3 years younger, then she would be 27. Okay? There are 12 crackers in each box. How many crackers are there in 2 boxes? This is where now we get into multiplication. Very easy. If we know there are 2 boxes of them, then we do 12 times 2. Okay? And get 24. That's pretty basic stuff there. Okay? But why I show you that is to show you the expression, the numeric expression, which would be taking the part, which is that there are 2 boxes, and then multiplying it by the other part, which is how many are in each box. And then you can just multiply. But real quick, I just want to show you this because it's amazing how everything comes back to proportions. Right here, this right here is a ratio. Okay, we know that there are 12 crackers in 1 box. So we want to know how many crackers there are in 2 boxes. Times 2 times 2. Everything with multiplication and division comes back to some proportion. Okay? So if you're ever confused, I know this is an easy problem, but you can always set up the fake ratio and the proportion. Okay? Now, this is where it gets different. This is now we don't know the exact amount of crackers in each box, but we're given an unknown number, a variable, to represent it. Okay? So if I know that there are 4 boxes, 1, 2, 3, 4, and there are z in each one, then it would be just 4 times z. The other way to think about it is, wouldn't it just be z plus z plus z? Okay, same thing, right? Isn't multiplication just repeated addition? Okay, later on in this chapter we're going to talk about like terms. Okay, the terms in this problem would just be z, 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 or 1z, 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 and 1z, because there's just one of them. Okay, it's not like 2 z's. Okay, what we do when we simplify is we actually combine like terms and we say, well, how many z's do I have? I have 4 z's. 4 times z. It's the same thing. Okay? And then you can read what she's saying, and you can see that she can say the product of 4 and z, or the product of z and 4. Okay? Now, just so you know right now, when we write multiplication algebraic expressions, we never put z4. We never put z times 4, quite frankly. We always write it with the number directly in front of the variable touching it. Okay, and you should know that because that's something we've covered on review sheets. Go to the next page. Okay, same thing here, only now we're going to talk about division problems. Okay. A 12-inch rod is divided into 3 parts. So if we know the whole amount, remember division's whole divided by part equals part. If we know the whole, we can divide by 1, 2, 3, and then that will give us how much is in each one, which is 4. Okay. Well, same goes when you have a variable. Okay. You know the entire length is w, works out because whole w, right? And we know that there are 7 pieces here, so here this would be w divided by 7. Okay. Remember, all fractions are division problems, so that means that all division problems are also fractions. So this could also be written as w over 7. This could also be represented by this, but I don't think you're really going to understand why right now, so don't really worry about that, but you will. That'll make more sense later. Okay, so w divided by 7. We'll do a couple of these right here. The product of z and 6, product means multiply. So remember, you could. I don't want you to write 6xz. Okay, remember, from this point forward, guys, the x for multiplication, get rid of it. We're not using it anymore. We're done. We're done using the x for multiplication because we are squarely in algebra mode, which means we use x as a variable and not an operation. So don't use it. So that wouldn't be accepted. Even this 6.z, even though it's correct, it's not proper notation. Whenever we're showing multiplication of a number by a variable, we write 6z. The number in front is called a coefficient. Make note of that. It's called a coefficient. It's not really important right now, but in Learning Target, I don't know, one of the ones coming up here, that's part of the learning target, being able to identify what a coefficient is. It's the number directly in front of the variable. Okay? The quotient of W and 8, well, if it just says the quotient of W and 8, then you know that's the order that it wants it in. So we could write it as W divided by 8, or the way I would rather you write it, which is a fraction form, because all fractions are division problems. Okay? Let's go ahead and go to the next page. Write an algebraic expression for each of the following. Okay, the sum of 4 and p, so we got 4 plus p. Or, could you write it as p plus 4? And why can you do that? Because of the commutative property. Okay, number 2, this is the one I said to be careful of. The difference 8 less than q. Okay, if it's 8 less than q, then that means q minus 8, because it's 8 less than that whole amount. Okay? The product of 3 and r, we have 3r. Okay? And the quotient of s and 5 would just be s divided by 5. But the better way to write it would be s over 5, writing it as a fraction. Okay? All right. We're going to just skip these for now. I think, you know what, let's just skip down to number 6 here. Okay. This is now going to start to get into 2 steps. So multiply k by 5. So how would we show that? Hopefully you're all saying 5k, right? Then add 3 to the product. And it says add 3 to the product because this is the product. And the order of operations says you must do multiplication before addition. Okay, here we go. Divide m by 7 and then subtract 4. Okay. Divide j by 9 and then multiply it, and then multiply the quotient by 2. Okay, just like that. Divide j by 9 and then multiply the quotient by 2. And it says the quotient because it's saying the quotient of j and 9. Notice these are the answers. You're not going to get an actual answer. Okay, now I want you all to see this right now. Everybody identify the word of right here. Of. Of means, in math, always means multiply. Okay? If I said, give me half of it, then you're going to multiply half times whatever. If I have 20 papers on my desk, and I say, hey, give me half of them, you do multiply times half. What is 20 times 1 is 20. 1 times 2 is 2. What is 20 divided by 2? Wouldn't half of them be 10? Okay, so the word of means multiply. So we want the sum of 1/3 of z. So that's going to mean 1/3 z plus 1/5 of z, which is multiplied by z. Okay? Alrighty, let's do these last couple here. These are very important. These are we put these on here this year because these are just like the part questions. Okay? This is these, you've seen them on review sheets. Select all that apply. These can get tricky at times, guys. Okay. Which of these expressions represents the sum of 3 and n? So, we know that the sum would mean the answer to an addition problem. Okay. So, I know that this would be 3 plus n. This would be n plus 3 also because of the commutative property. So let's look at A. Would A represent the sum of 3 and n? No. That's representing multiplication. 3 times n, the product of 3 and n. So that wouldn't work. N plus 3? Yeah, that would work. What about 3 plus n? Yeah, that would work. What about n, n, n? No. It doesn't say remember, repeated addition is just multiplication. Couldn't I also just do 3 times n? So isn't that the same as that? N plus n plus n is the same as n times 3. So that would be eliminated. And then n to the third, that's not saying that. It's not saying n times n or n to the third power. It's all about addition, so that one would be eliminated. So the only two that would be viable answers here would be these two because of the commutative property of addition, which says order can change and it won't impact the outcome of the answer. Okay? Do another one of these. It's the same type of question here. The product of 4 and m. Now, product means multiply, so hopefully you all right away are thinking that because that's the best way to write it. Okay? Now, there are other ways to write multiplication. This is just the best way. This is the prime best way that I want you to always do it. But I mean, technically, you could do 4.m. You could do m.4. Again, you can change the order because of the commutative property. Okay, you could use an x. Ugh, I hate even saying that, but you could, I guess. It wouldn't be right if you did it for me, but I'm just trying to write all the possible things. Another way to show multiplication is with parentheses. And of course, we could put the m here and then the 4 here. I mean, there's just many different ways. We could use an asterisk, which is like that little star thing, and you could flip the order once again because of the commutative property. So all these are possible here. Okay. So obviously, A would be correct, not perfect notation. Again, I want this when you're showing multiplication of a number times a variable. You put the coefficient, then the variable. This one here. This is interesting. M plus m plus m plus m. Would that? Yeah, because once again, remember, multiplication is just repeated addition. So that means, since you're adding the same thing to itself, you can say, well, I know m, and I'm adding it 4 times, so that could be 4m. So absolutely. Okay, here's a little bit of like terms things that you're going to learn here in the next chapter. Or not this, in a few learning targets from now. If we have 3m and we have 1m, we can combine those because they're both m. Okay, so therefore, yes, that would absolutely be the product of 4 and m. It looks weird, but you could. Okay, now this one, 4 divided by m, that's if you don't know the word product, then you're probably going to maybe think d, but that would be wrong. This, again, if you thought the sum of m and 4, it says product though. Okay, and then obviously F would be the best way. Everybody highlight it, or if you don't have a highlighter, just kind of circle it bigger. That's the one right there. This one is showing the quotient of 4 and m. This one, 4 plus 1 is 5 plus m. Okay, we can combine like terms since they're the same number. So no, that wouldn't be the same. And then m times m times m times m, that would actually be m to the 4th. That isn't what that says. It doesn't say the product of m and m and m and m. It says the product of 4 and m, so that would not be correct. So the possible answers are A, B, C, and F. Okay, so hopefully this all makes pretty good sense. It's very important to know those words on that page 2, though. Okay, all right, see you guys.